The Prince of Peace Aeronautics and Space Administration wants to simulate gravity by having two space stations tethered together with a 2-kilometer cable stretched between them. Each station would rotate about a common center with a tangential velocity of 109 meters per second. Astronauts on board want to make a pendulum with a period of exactly 1 second. How long must the pendulum be? Ever since space technology began, engineers and dreamers have speculated about simulating gravity by tethering two stations together and having them separated. In this case, we're having a radius of 1.0 kilometers and a total tethered line of 2 kilometers. They would rotate around each other, and recall when we did a bob that we rotated around in a circle, that we calculated the centripetal acceleration of that circle. So this will be a problem similar to that. Now they want to make a pendulum, and we know that the period of the pendulum, t, is equal to 2 pi times the square root of L, the length of the pendulum, over g. At least that's the way we remember it. But remember, this g is the acceleration of gravity on Earth. If you're not on Earth, this becomes whatever acceleration that you have. So now the period of our pendulum is 2 pi times the square root of L over whatever this acceleration might be. So let's solve for the length of the pendulum. And in solving for the length, we get L equal the period over 2 pi quantity squared times the acceleration. But this acceleration is the acceleration that we calculate here by the two spaceships going around in circles with each other. And we know from our study before that this acceleration is equal to v squared over r, where r is the radial separation here, and v would be the velocity, tangential velocity. So we have the length of the pendulum is t over 2 pi squared, and the acceleration just becomes v squared over r. To simplify the algebra, we can bring the v inside the square, and so we have t times v, the period times the velocity, over 2 pi, quantity squared times 1 over r would be the length of the pendulum. Putting our numbers in, we have 1 second here for the period. The velocity is 109 meters per second, and over 2 pi, that quantity squared, and then we have 1 over 1,000 meters. When we put those numbers together, we get an answer of 0.301 meters for the length of this pendulum. And we keep 3 significant figures here because we have 3 here in meters per second and 3 in the length of the cable. So the period of the pendulum would be 0.301 meters. But we solve this problem by looking at tangential acceleration and putting it back into the equation for the acceleration in the period of the pendulum.